Hello, in this video, we're going to focus on dividing by a double-digit divisor. In these problems, we are going to use an area model following partial quotients. The first thing I like to do when I see a problem like this, I notice that I have a double-digit divisor. I'm going to multiply that divisor by powers of 1, 2, and 5. This way, it just makes it a little bit easier when I actually get to the division. The first thing what I mean by that is the first thing I'm going to do is 15 times 1 equals 15. Now I'm going to take 15 times 10 is 150, and 15 times 100 is 1,500. Now I'm going to take my divisor again of 15, and this time I'm going to multiply it by 2. 15 times 2 is 30, 15 times 20 is 300, and 15 times 200 is 3,000. Now notice this pattern here, and in fact, I know we've been working on multiplying by powers of 10 here. We're going to follow the same process we've learned previously. And last but least, I have 15 times 5. Now, if you need to write this out on the side just to confirm what 15 times 5 is, that's totally fine. 15 times 5 happens to be 75. I'm going to do 15 times 50 is 750. And 15 times 500 is 7,500. Now notice this is the first thing that I am doing. I'm going to do this for every type of problem like this because now once I have this information here, it's going to make my division much, much easier. So before I get to any division, I like to do this first. Now I chose multiplying my divisor by 1, by 2, by 5 because those are easy numbers to multiply. A lot of times we know what 15 times 1 is. And even multiplying by 2 or by 5, those are quick, simple multiplication facts typically that hopefully is pretty easy and simple for you to do. So now, after I do this, which I do for every problem, I'm going to draw my rectangle. Now, this is how we're going to do an area model. Here's my rectangle. I'm going to put my divisor on the side. My dividend is going to go right underneath here in the corner of my rectangle. I'm going to draw a line here separating the two steps. Now, my first thing I'm going to do is I'm going to look at all my products on the side. What number gets me really, really close to 3,180? I happen to see here that 15 times 200 gets me really, really close. Now notice I already did the multiplication, so I'm not guessing and checking on the side here. I already have it done. So now I take 15 times 200. 15 times 200, guess what? I already have it done. It's 3,000. Now, yes, some of you might try to guess a little bit closer. Maybe you might do 15 times 205 could get me even closer. And you can continue on until maybe you get exactly to 3,180. But instead of doing that on the side and guessing and checking all those multiplication facts, I might as well use what I already have. Now, there's no harm in doing that. If you want to do that, that's fine. But I like making my life much easier for myself when I solve these multi-step problems. Use what's already given to you. Now I'm going to subtract and I'm left with 180. So I'm getting closer, but I can still continue making more groups of 15. So I'm going to place that 180 on top here in a new step. So let's do my new step in green. Now I'm looking here and I see, okay, 180. What can I get to close to or exactly to 180? Well, I noticed here is 150. This is great. Let's do 15 times 10. Now 15 times 10 is 150. Now I'm going to subtract and I'm left with 30. So I'm going to draw a line and I'm going to move this 30 to my next step. Now, some of you might realize, okay, well, maybe I could do 15 times 11. Maybe I could do 15 times 12. That's fine. If you want to do that, you're welcome to do that. However, I already have 150 here, and that's fine. I already did the multiplication. I don't have to guess and check again on the side. So again, I might as well use what I already have. So now I'm going to go in red for my last step. Well, 15 times some number is in fact exactly 30, and I see it right here. 15 times 2, I'm going to put my 2 above here, and 15 times 2 is 30. Now I'm going to subtract to see if there's a remainder or not. I notice that I do not have a remainder. So now my last step is finding the quotient. What is the answer to this problem? And in fact, your homework has been problems like this. And your homework, I completed the problem. I solved it. But your step here is to determine, looking at the work, where am I going to find my answer? So I find my answer by looking on top, and I'm going to circle all the numbers on top, which in fact is my answer in expanded form. So now what I can do is I can add 200 plus 10 plus 2, giving me 212 as my quotient. So like your homework last night just required you to look at the problem, and your goal was to find where the answer was in expanded form and add everything together, and using the work to determine the quotient. So you do all this work is great, but you also need to represent your quotient. And the answer to this problem, or my quotient, is 212. So now let's try one more problem. This problem, let's go a little bit larger. We're going to do 5,214 divided by 39. So just like I did for the previous problem, 39 times 1 is 39. 39 times 10 is 390. 39 times 100 is 3,900. I'm going to draw a little line now. I'm going to go by 2. 39 times 2. Now again, you can write this on the side if you need. Some of you might be able to do it in your head, but if you want to confirm you have the correct answer, write your work on the side. 39 times 20. Now notice 39 times 2 is 78, so 39 times 20 is 780. And 39 times 200 is 7,800. Now, yes, this answer is in fact larger than my dividend. So do I really need this? No, but it's just part of my process. I like to do this every single time, but if you realize that's too big, you don't have to include that. And 39 times 5, again, same thing. If you want to write this on the side, I always recommend you do it so you can confirm you have the correct answer, is 195. 39 times 50 is 195, include my 0, giving me 1,950. And if I do 39 times 500, I see that I have 19,500, which honestly is impossible to use. But if you want to include that anyway, it's fine, but you're not going to be using this multiplication fact here. So now I did my multiplication. That's step 1. Now I can begin the area model. And it's great because I already did this hard work on the side. So now I'm going to draw my rectangle. My divisor is going to go on the side. I take 5,214. I'm going to draw a line just to represent this as step 1. So looking at my work here, I'm going to look around and what number do I see that's close to or exactly to 5,214? Now looking here, I happen to see 3,900 or 3,900 is the closest I could get. So 39, let's do this in blue. 39 times 100 is in fact 3,900. So let's subtract. Notice we have to borrow here, that's absolutely fine, is 1,314. So I'm going to bring that up here. Now my next step here, I'm getting much closer. I'm going to look on the side and what number gets me really, really close to that? Where can I get that's pretty close? Now I see here that 39 times 20 does get me pretty close. Yes, I could definitely get closer, maybe 39 times 40 or maybe 39 times 30, but I happen to have 20 here, so that's fine if I use that. You might want to do on the side and get even closer, that's fine. It's the beauty of these problems. You could do it so many different ways. So now I'm going to subtract, and I'm going to borrow. No big deal, just going to borrow. So we have 12 minus 7, which gives me 534. Now I'm going to include 534 here and move to my next step. Let's do this one in red. So I'm looking here and I'm trying to determine, well, what number gets me close to or exactly to 534? Now I'm looking at what I multiplied on the side and I'm like, wait, actually 390 is pretty close. So 39 times 10 is 390. I'm going to subtract. Don't forget to borrow. 13 minus 9 is 4. 4 minus 3 is 1, giving me 144. I'm going to draw my line and move to my next spot. So let's do this one in blue. What number is going to get me close to or exactly to 144? Well, I see 195 is close, but that's too big. So let's do 39 times 2. Yes, on the side, maybe 39 times 3 gets me closer. Maybe 39 times 4. And if you want to do that and eliminate the last step, that's fine. But I like to use what I already did. I don't want to have to do more multiplication. So 39 times 2, let's see, is 78. So again, I'm just going to borrow real quick. No big deal. So 14 minus 8 is 6. 13 minus 7 is 6. So I get 66. Now I'm getting really, really close. I have 66, and I see here, well 39 times 1, 39. 39 times 2 is 78, and that's too big. So we're going to use 39 times 1. So let's subtract, and let's determine if we have a remainder. So again, we have to borrow, but again, that hopefully should be no big deal. 16 minus 9 is 7, 5 minus 3 is 27. So even though 27 is a large remainder, I do know that that is correct because my remainder is less than my divisor. So our goal with this divisor is to create groups of 39. Obviously, if I only have 27 left over, I can't make a full group of 39. So therefore, my final answer is going to have a remainder of 27. And when you're dividing by these large divisors, you might have a large remainder, and that's okay. So again, you had problems just like this on your homework. The last step that you're going to do here is add all these numbers up top here. Okay, so I'm going to take 100 plus 20 plus 10 plus 2 plus 1. So when I add these together, I get 133. Now 133 is really close to my final answer, but I also have a remainder of 27. So yes, this is a large answer. We have 133 groups of 39 with 27 left over. But if you choose to follow this area model, I promise you with just this subtraction, you will be able to get your final answer. You're tearing that large dividend apart and determining how many groups of 39 can you create. So as always, feel free to refer back to this video at any time to help you with any problems regarding area models.